day, everyone. You're welcome back to Born to Talk channel. The last time we talked about direct variation, we've talked about inverse variation, and today we'll be talking about joint variation. And when we're talking about joint variation, under inverse and direct variation, we are talking about just two variables, but in joint variation, it combines three or more variables together. Let me give an example. Welcome back. This is an example under joint variation. It says the volume V of a cylinder, the volume V of a cylinder varies as the product of the value of the square of its radius r and its height h. This is a typical example of a joint variation whereby your V varies to r and also h. But how does it varies to it? It says varies as the product of the value of square of its radius. That is, your V varies to the value of the square of its radius and height h, and it says the product. So it means the product of the value, the square of its radius r, which is the square of r, and its height h. So v varies to the two, and if you are to introduce the constant, your v equals to kr square h. And therefore, if you're looking for your constant in this way, your constant k is equals to v over r square h, which will be your final answer if you're looking for the constant. And this is a typical example on joint variation. Let's do some calculations using this example under joint variation. This is a calculative example under joint variation. It says given that p varies jointly as s and v squared, and that p is equals to 18, s equals to 9, and v equals to 15. Find v when s equals 81 and p equals 32. This is very simple to go about. Then our solution, let's go on. Our solution Our solution would be, let's firstly derive the formula that combines all this together. They said P varies jointly as S and V. That is, your P varies jointly as S and V squared. Since they did not talk about it being an inverse, they just say it varies. So if you hear varies without them indicating maybe it is inverse or any, so you can just use a direct variation. And if you introduce a constant, your p is equals to sv square, and from this you can divide both sides by sv square. Then you will be having k to be equals to p over sv square. So you'll be having p over sv square. So your k is equals to, what's your p? Your p is 18 over your s is 9, multiplied by your v, which is 15 squared, equals to 18 divided by 9, you have it to be 2, and your 15 square is 225, so you have 2 over 225, and that will be your k. Your k is 2 over 225. So now that we've gotten our k to be 2 over 225, we just have to leave it aside and come to the formula that says p equals to, because of the space, p equals to ksv squared. We need to make this v subject of the formula, thereby we transfer this ks to the other side, so you have v squared to be equals to p over ks. But mind you, we need only v, not v squared, so your v now is equals to square root of p over ks. If you're wondering how I transfer this square root from this side to the other side, I'll drop the link to a video whereby I explain the elimination of square to square root there. There's a short video I've done on that, and please try and watch so that you can get it. So since we know our v now to be this, so you substitute the value whereby your p is equals to what? 32 over your k is 2 over 225 multiplied by your s, which is 81. So you can simply write this equation by saying v is equals to square root of 32 over 81 multiplied by 225 over 2. So 2 here cancel here, 2 here you have 16, then 9 here 9, 9 here 25. So you'll be left with v to be equals to square root of 16 multiplied by 25 over 9, and your v is 4 multiplied by 5 over 3. If you find square root of each and every one of them, square root of 16 is 4, of 25 is 5, and of 9 is 3. So you have 20 over 3. So your v is 20 over 3, which is the same thing as 6 whole number. You have 2 over 3. And that's your final answer for v. And with this, you are able to use a joint variation between joint variation of p between s and v to look for anything you're looking for between s, v, and p. And I would like us to do one more example on joint variation before we move to the next, which will be a partial variation. This is the second example I bring on joint variation. They said if d varies as s and inversely as square of t, and when d equals to 6, s equals 24, and t equals 5, find s when t equals to 12 and d equals 0.4. D varies directly as s and inversely as square of t, that is 1 over t square. You can simply write this equation by saying d varies as s and also as t square. And if we want to eliminate this variation sign, your d will be equals to ks over t square. From this, you can make k subject of formula. The first thing you do is you cross multiply your ks equals to dt square, and your k equals to dt square over what? Over s. So let's look for our k from this formula. Our d is 6, k equals to d is 6 multiplied by our t is 5, which is 5 square, over our s, which is 24. So you have 6 multiplied by 25 over 24. So 6 here 1, 6 here 4. You have 25 over 4. You have 25 over 4. That is your k. So now they said find s when t is 12 and d is 0.4. That is, we have to make s subject of the formula. We have to make s subject of formula. To cut the long story short, we can just come here in this equation that says ks equals to dt square. Instead of you dividing both sides by s to eliminate s here, you can just eliminate k from here. And with that, you will be having s to be equals to dt square over k. And that will leave us to our d to be 0.4 multiplied by our t is 12, which is 12 square, and our k is 25 over 4. Equals 25 equals, so you can write this by saying 2 over 5 multiplied by 144 multiplied by 4 over 25. So you have 2 multiplied by 144 multiplied by 4 over 5 times 25. So you have it to be 1152 over 125, and 125 in 1152, that's 9 whole number 27 over 125, and this is the value of your s. It is 9 whole number 27 over 125. And this is all about joint variation. If you have any other examples on joint variation that you would like me to solve for you, please drop it in the comment section below, and I will drop the answer for you as soon as possible. Please don't forget to like this video, subscribe to this channel, and on your notification bell So anytime I drop a video or any other tutorial, you'll be notified immediately. And don't forget to share. Thank you very much.